Okay, so what I want to do is show you very quickly, hopefully not too fast so you can't follow along, but quick enough so you can understand what to do for this problem. So what we want to do first for this problem is determine the end behavior and then also determine the zeros and the multiplicity. First thing when determining end behavior is you look at your degree. If it's even or odd, you're going to look at two certain cases. Since this is odd, my graph is either going to fall left, rise right, or it's going to rise left, fall right. That all depends on the coefficient. Since the coefficient is positive, by the leading coefficient test, my graph is going to fall left and rise right. And this will help you as far as when you have your zeros, as far as graphing your polynomial if need be. Now the next thing we need to do is find the zeros. So to find the zeros, I got to make sure I set f of x equal to 0. Why do you set f of x equal to 0? Because remember, f of x is your output value, which is pretty much the values on the y-axis. So when that equals 0, you're going to find the values that are going to lay on the x-axis, which will be their intercepts. So here what we need to do is determine what the values of x are. So I can't solve for this. It's not linear. And right now it's not looking like a quadratic, although it's very similar. I have three terms. So I'm going to want to look into some factoring terms. And the first thing I do is always see what are common factors that I can factor out. And what you notice is all three of my terms share an x. So I'll factor out an x, and I'm left with x to the fourth plus x squared minus 6. Now still you might be looking at this and say, you know what, it looks so close to a quadratic, but it's just not there. It's to the fourth power. So what I want to do to help you factor, you don't have to do this, but one thing that I've found with students that helps them out is I do substitution. So what I'm going to say is I'll say x to the fourth now equals x squared, and x squared now equals x. So what I'll do is I'm just going to go and factor this to the side as x fourth is x squared plus x minus 6. So by doing this, what you notice is this factorable? Yeah, of course it is. I can factor that is to x plus 3 times x minus 2. Now you can see that it's been factored. And what I can do with this now is resubstitute back in my values. So by doing that, what I get is 0 equals x times x squared plus 3 times x squared minus 2. And you can see, does this actually work as the factored version? Well, does x times x squared equals x to the fourth? Yes. And then when you do your middle terms, you'll get x squared. And then 3 times negative 2 gives me negative 6. And it works out. Yippee. So now what we need to do is we see all of our factors equal 0. We can apply, since they're all being multiplied, I can apply the zero product property. X equals 0. Then x squared plus 3 equals 0. And then x squared minus 2 equals 0. So by solving for x here, I get x, well, first of all, let's go and solve each one. So therefore I get minus 3, so that's going to be imaginary. So right now we're not going to work about imaginary roots. We'll talk about that later in the class. And then here I'm going to have x equals plus or minus the square root of 2, and here x equals 0. Now the next thing we want to talk about is the multiplicity. Multiplicity, if it's odd, is going to tell you that the 0 is going to cross the x-axis, and if it's even, it's going to tell you it's going to touch and then rebound back up. And we look at the multiplicity by looking at the exponent of your factors. And what we notice is each one of these have an exponent of 1 of the factor. So therefore, these are all zeros of a multiplicity of 1. And that's your imaginary, which we're not going to talk about now, but it's still a root, just not real. Thanks. Bye.